Hey everyone, hope you're doing well. This video is going to be a big one, all right? This is, not brand new, but taking something that we've done before and, really bulking it up a bit, all right? This is systems with 3 variables. So in order to do a 3-variable system, you need 3 equations, right? Because you need as many equations as you do variables. So this video is actually going to split into 2 parts because these notes are going to be split into 2 days. So we're only going to be covering the first page today, which is going to be 3-variable systems using substitution, all right? In the other video, we'll do elimination, and we won't cover graphing because you guys don't know how to graph with 3 variables, right? You know how to graph with an X and a Y, right? 3 variables, that's like a 3-dimensional graph, and that's something completely different. So substitution, all right? The way to do this, there are a couple different ways, all right? The first one we're going to do is like an easy version, all right? We're going to kind of walk you into this. If you look at this first equation, there's actually only 1 variable in this equation already. And remember, your goal is always to constantly be going to less and less variables. So if we actually take this first equation and divide by -4, that gives us, x equals, because that'll cancel out, 16 divided by -4, that'll give you x equals -4. So we know a variable right now, which is nice, all right? So now we can use that, we can plug that in. And if you look at the second equation, okay, you can see how this one is kind of built for you. The second equation just has x and z. So if we plug -4 here in for x, now we have a single variable equation and that we can actually solve for z. And this is kind of what you're doing. Now, it's not always going to be this easy, so we'll look at some harder ones too, but we plug that -4 in, this gives us -8, and then we can solve this out for z. So add 8 over to both sides. So we got -3z equals 6, divide by -3, and we have z equals -2. So there's our second variable that we know. All right, so for this third equation where we have all 3 letters, well, we already know 2 of the letters, right? We know 2 of the variables, so we can actually plug both of those in here. So we can plug in -4 for x. We don't know y yet, so we just got to put -7y. And then we know z is -2. So we plug in -2 there, and that's going to equal -22. And so what we can do with this is, solve this out. So this is -12. That's -4. We can combine like terms. That'll be -16. Add that over to the other side. -7y equals -6. So y equals 6/7. I don't know, that doesn't seem right to me, but maybe I made a mistake somewhere. I don't know, it doesn't seem like I made a mistake. If I made a mistake, send me a message and let me know. But I think that's the answer. So we got x equals -4, z equals -2, and y equals 6/7, okay? So there we go, all right? Now, all right, so that's the easy method, get the first one, plug it in, get the second one, plug them both, and get the third one. Now, what if you can't do that, okay? So if you look here, we don't have a single variable equation. So there's no variable that we can just go ahead and solve right away, okay? Well, we do have a letter by itself. And as you guys know, if we have things by itself, we can plug them in. So we know that y equals -z. So we have to take -z, and we have to plug that in for y. Now, you can pick either equation. I'm just going to do the second one just because there's not really a difference between the two. They both have all 3. So we have 4x minus 2, parentheses, -z, plus 4z equals 18. Okay? So what do we have now? Now we have a 2-variable equation. right? Now we have 4x. This turns into plus 2z. We got to start combining like terms. So we've got 4x plus 6z equals 18. Now we have to decide here, do we want to get x by itself or do we want to get z by itself? Because we got to get one of these two by itself so we can substitute it in for the other. And actually, since we already have y in terms of z, we pretty much have to get x in terms of z. So let's solve for x, all right? So that'll give us 4x equals negative 6z plus 18. Now we got to divide by 4. And that gives us x equals negative 3 halves z plus 9 halves. That sucks. Man, more fractions. Okay. So now we have x in terms of z and we have y in terms of z. So this is why I said this is kind of an intensive process, all right? Now we go into that bottom equation. And now we got to substitute for x and for y, both in terms of z. So we've got negative 3 halves z plus 9 halves. That's in for x. Then y is negative z plus z equals negative 6. So we have to solve this. So first thing I'm going to do is my multiplications. This will be negative 9 halves z plus 27 halves minus 3z plus z equals negative 6. So now I need to combine like terms. You know what, I'm just going to turn this into a decimal. This is negative 4.5. Halves are easy to work with decimals. This one's going to be 13.5. Okay, so this is going to be negative 7.5 plus z, so negative 6.5 z plus 13.5 equals negative 6. Subtract that to both sides. So you got negative 6.5 z equals negative 19.5. What? No way that goes in. Oh, wait. Does it go in 3 times? I spoke too soon. I think negative 19.5 divided by 6.5 might be 3. It is 3. Okay. Whew. So we're done with that. All right. Z equals 3. Nice. Okay. So what do we do now? Well, now we can get x and y. All right. And because of our work earlier, we already have x in terms of z and we have y in terms of z. So we can just go ahead and plug those back into those two equations specifically. So the y one's easy. We know that y equals negative z. Z is 3, so y equals negative 3, so that one's done. And then we have x equals negative 3 halves times 3 plus 9 halves. Is x 0? Yeah, because that'd be negative 9 halves plus 9 halves, so it looks like x is actually 0. And so we're done with that problem. Okay, so we got z equals 3, y equals negative 3, x equals 0. So believe it or not, that is how you solve that problem. Okay, we're done. One more to do. This one looks kind of tough. All right, number 3. All right, so what are we looking at? Well, the first thing I see here is that we have y by itself, okay? So if we got y by itself, that means, okay, I'm trying to think about the quickest way to go about this problem, because It seems like they want us to plug this in, but what do they even want us to plug that into is the question. It seems like they want us to plug it into here. So I'm just going to go with that, and we're going to see in this video how this works out. All right, so 5x minus 4x plus 3z plus 21 equals negative 11. So we got to distribute our negative sign. So that's minus 4x minus 3z minus 21 equals negative 11. Okay, 5x minus 4x, that's x minus 3z minus 21 equals negative 11. I'm going to add both of those over to the other side at the same time. All right, so negative 11 plus 21, that's going to be 10. And then I'm going to add the 3z over as well, but those aren't like terms, so we'll just get 10 plus 3z. So now we have x equals 10 plus 3z. Okay, but we need something else in terms of z. Should we just plug that into the top equation? It seems like we need to get z by itself in terms of x. Okay. Man, we made this question hard. Okay. And this is why you don't want to do substitution. When we do elimination, it'll be better. Okay? I think we need to get it in terms of z in terms of x, not the other way around, not x in terms of z. Because we have no way of getting y in terms of z. Actually, we do. I guess we just got to plug this into the top equation. I guess we got to plug both of them into the top equation. I think maybe we just didn't pick the right way of going about this. So we've got 5, 10 plus 3z. But we're plugging an x into that equation as well. Okay, you know what? We're just not going to worry about this question. The one that I put on the skill check is not nearly as hard as this one. This one's going to be really long. If there's one on the practice like this, give it a shot. See if you can follow it through. But this video is already getting kind of long, and I don't want to lose people. So if you can do the first two, then you're good. All right. If you have any questions, let me know, and have a great day.